You know that feeling, right? That little knot of fear every developer gets when they have to change a piece of code? Well, today we're going to talk about how to get rid of that feeling for good. We're diving into unit testing and how it builds a powerful safety net for your work so you can code with confidence. All right, let's get into it.
So picture this. You just pushed a brand new feature. It works perfectly. High fives all around. But then, a week later, you get a bug report. A completely unrelated change you made somewhere else has somehow, inexplicably, broken your beautiful new feature. It's a total mess, and now you have to drop everything and figure out what went wrong. We've all been there.
Yeah, that painful step backward. It has a name. It's called a regression. And it's when something that used to work just fine is now broken because of a new change. It is, without a doubt, one of the most frustrating things about being a developer. So the big question is, how do we stop this from happening?
Well, back in the day, the process was pretty terrible. Developers would just write a ton of code and then basically throw it over a wall to a totally separate team, the QA team. You'd wait forever to find out if you broke something. The modern way, though, it's a complete game changer. Testing isn't an afterthought. It's something you, the developer, do constantly as you're writing the code.
To really get a handle on this modern approach, we have to learn to think small. I mean, really small. Instead of trying to test your whole application at once, we're going to zoom in and focus on the tiny individual building blocks of your code. We're going to think in units.
So, what is a unit exactly? Well, think of a single function or a single method. That's it. That's a unit. It's one tiny, self-contained piece of logic. And unit testing is just the simple act of checking that one tiny piece to make sure it does its one job perfectly, all by itself.
Now, before we get into all the cool automation, let's just think for a second. How would you test a simple function by hand? Let's say you just wrote a basic divide function. How would you prove to yourself with total certainty that it works?
You'd probably do something that follows a really natural pattern. It's called arrange, act, and assert. First, you arrange everything you need for the test, like your inputs, say the numbers 10 and 5. Then you act. You actually call your divide function with those numbers. And finally, you assert. You check the result. Did you get back 2 like you expected? If yes, great, the test passes.
Now that logic is rock solid. But can you imagine doing that for hundreds of functions manually? It would be an absolute nightmare of print statements and manual checks. It's slow, you're bound to make mistakes, and it just doesn't scale. We need a much better way.
And that is where a testing framework swoops in to save the day. For anyone working with Java, JUnit is your new best friend. It's a tool built specifically to take that tedious arrange, act, assert process and put it on autopilot, making your tests fast, reliable, and super easy to run. Let's see what that looks like.
Honestly, the difference is just night and day. Manually, you're writing all this extra code just to run a test, creating objects, calling methods, writing clunky if-else statements to check the result. But with JUnit, you just tell it what you expect to happen. The framework does all the boring setup and teardown for you.
Just look at how clean this is. This one line does the same job as a whole messy if-else block. You're just making a simple, clear statement. I assert that the result of dividing 10 by 5 times equals 2. It's easy to read, it's concise, and all the hard work is handled by the framework.
And the best part? You get feedback instantly. You run your tests and you see either a beautiful, glorious green bar that says everything passed or a big, glaring red bar. And that red bar doesn't just tell you something is wrong, it tells you exactly what is wrong and where it broke. Catching bugs doesn't get much faster than that.
Okay, so once you're comfortable writing tests for code that already exists, you're ready to unlock a genuine developer superpower. It's called test-driven development, or TDD. And the big idea is this. What if you wrote the test before you wrote the actual code? It sounds backward, but trust me, it changes everything.
The TDD cycle is this simple little rhythm. First, you write a test for code that doesn't exist yet. And of course, it fails. That's your red step. Next, you write the absolute minimum amount of code needed to make that test pass. That's your green step. And finally, now that you have a passing test as a safety net, you can clean up and improve your code. That's refactor. It's a cycle that actually forces you to write better, cleaner code from the start. And don't think junit is just a one-trick pony. It can answer all sorts of complex questions about your code. It can check if your code throws the right kind of error when it's supposed to. It can even check if a function runs fast enough. It's an incredibly versatile toolkit.
So think about it. When you combine all these little individual tests, Hundreds, maybe thousands of them, each one checking a tiny piece of your application. You're not just writing tests anymore. You're building something much, much bigger. This whole collection of tests, that is your safety net. It's this system that you can run in seconds, and it will tell you if your latest change broke anything, anywhere in the entire application. And that gives you the freedom, the confidence to make changes, to improve your code, and to innovate without that constant fear of breaking things. So why does all this matter so much? Well, here's the bottom line. Unit testing gives you the confidence to refactor your code without fear. It catches bugs early when they're small and cheap to fix, and it acts as living documentation, helping other developers, and even your future self, understand what your code is supposed to do.
I'll leave you with this one final thought. With a good set of unit tests, you're not really testing your code anymore. In a way, your code is testing itself constantly. It becomes this self-aware system that can tell you instantly the moment something goes wrong. And for a developer, that changes everything.